Hey everybody, welcome back. So in today's video, we're going to be discussing the addition of the WAN connectivity into our data center. So in the beginning of the last video, I had made mention that I put the WAN routers back in. So these are Catalyst 8 KVs, okay? The idea behind this is that we're going to have two WAN routers, and we are going to have connections up to the MPLS cloud, all right? And just for fun, Router 1 is going to home to service provider Router 1, and our Router 2 is going to home to service provider Router 3. We could connect to any one of these in theory. Well, we can connect to either one, or we can split them for the demonstrations of this lab. Some of the considerations in real life for WAN connectivity to your data center would be, obviously cost. How much is this service provider charging us for these circuits as compared to other service providers? Maybe it's the ability or the efficiency of how fast or quickly they can deliver these circuits. So there's obviously constraints and considerations to take into account when you're choosing a service provider. So that being said, what you would want to do is to get on the phone with the ISP, right, and give them a breakdown of your environment prior to signing any contracts. So explain to them that, hey, we have this data center, we have however many branch sites. In this case, we just have two simple branch sites, but maybe your environment has more. You need to try to determine how big these circuits need to be to support all of the load in your branch sites. If your branch sites are accessing workload that is predominantly in the data center, right? So everything that these employees need to reach is in the data center. You have to size your circuits appropriately, right? Both on the branch side and the data center side. So you start to have these discussions with the service provider. They say, yeah, no big deal. We can deliver, a 1 gig circuit for your router 1. We can deliver another 1 gig circuit to router 2. Fantastic. The next thing that you want to ask them about is what we call diverse paths. Okay, so diverse path is just, all that means is the circuit that comes down to our WAN router 1, there's two pieces to this puzzle. One is on the service provider side, one might be on the data center side. So the data center side might have circuits coming into, let's say, the north side of the building, okay? They might also have circuits coming in through the south side of the building, so opposite ends of the building, okay? And then from there, they leave the premises data center and they go off to, whether it's underground, aerial, whatever it is, fiber, to what we call a POP, or a point of presence. So the service provider that we choose, or that we're having conversations with, they're going to have these POPs regionally across, the world, if you will, right? So they're going to be all over the place. So the idea is that we want the circuit that comes to router 1, right? It leaves the data center in one direction and it goes to a point of presence for that service provider that is different from the circuit that we're landing on our WAN router 2, okay? And the idea is that if there's a fiber cut, or if there's an issue in a point of presence, it doesn't knock out both of our circuits, it only impacts one of our circuits. So that is the hope and the idea behind the redundancy there, all right? And obviously we have these landing in two separate routers, so we're giving ourselves hardware redundancy on top of it. So that's kind of the high level as far as, some of the things you want to consider for your WAN connectivity. Now, I went ahead and I kind of reserved some IP addresses that are within our range that we're going to go ahead and use for connectivity with these WAN routers and the service provider, as well as our devices in-house. Okay, so we haven't even gotten into routing protocols yet as far as IGPs, or interior gateway routing protocols. So since we're Cisco, right, and we're eating our own dog food, so to speak, we have all Cisco devices. Why not just run EIGRP, right? It makes sense. It's quick. It's efficient. So we will be running EIGRP between the cores and any devices that connect to the cores, with maybe the exception of the firewall. Okay, we can entertain that later. We'll be doing BGP, which is pretty evident, and the service providers typically will do BGP between them and you. So we'll do BGP between the service providers, but as soon as we introduce two protocols, we have to now think about route redistribution. Okay, so there's a lot of considerations to be made and had here. So we're not going to tackle it all in this video. What we will do here is we'll get basic connectivity between our WAN routers up to the service providers. Okay, we can peer BGP, that's fine. And then we'll just kind of take a peek at what routes we may be learning, what routes we're not learning. Because if you recall, the branch sites are doing nothing more than static routes to reach each other. Okay, we haven't introduced any routing from the branch to the data center yet, or vice versa. So that's all the conversation that we're going to be having. That's all the points I'm trying to drive right now. Right, we haven't talked about any of it. So we'll start small. We'll get the peerings up between the WAN routers and the service provider, and then we'll most likely take a break and chop this up into a couple videos. So we'll take baby steps here together. All right, so let's hop on WAN router 1. We'll start there. And the other thing that I'm gonna just make a point about now, and maybe we can come back later and revisit, is the concept of virtual routing and forwarding, or VRF. So I am not going to put this connection in a VRF. We're just going to slap an IP address on gig 6, which is the interface on our WAN router, and we're going to go about our business. Okay. Later on down the road, if we decide that we need some kind of cloud on-ramp connection, whatever it may be, maybe there's like some voice circuit that needs to come in, who knows, like whatever the case may be, we might want to start to consider VRFs to kind of keep the traffic separate. One idea that I had was to start introducing the internet back to the branch sites, and we can actually do like a DMVPN cloud between the branch sites and the data center. So we might want to land that internet circuit on these WAN routers, which probably a good idea to put them in a VRF, considering it's public IP address space, right? So I'm not going to muddy the waters with all that stuff now. I'm just trying to make the point that, we try to design around as much as we can forward think, right? We try to think as much as we possibly can, but we can't remember everything. We're human at the end of the day. So we're going to build it how we build it now, and then in future videos, I'll show you how to kind of undo it or change it to accommodate the addition of circuits and that kind of thing, and we'll see what kind of repercussions it brings. So at any rate, I'm going to kind of dirty up the screen a little bit. I'm going to stick our little cheat sheet for IPs on the left. I'll keep the terminal on the right, and let's just go ahead and get some IP addresses on here. So we're on WAN router 1, okay, so we're on this guy. We're going to put this address on our WAN router, and this address is going to be on service provider 1, okay? That's a /30. The only two available IPs are 1 and 2, all right? So we're going to go ahead and we're going to take this address and put it on this interface. All right? Very simple, very easy, okay? Now we're going to go to service provider 3. Whoops, I'm sorry. Service provider 1. Okay. And the reason I chose those addresses is because we already had the 1.1s to demonstrate our branch connectivity. Okay, one was VRF Acme and one was VRF Cisco. So now we have to, as a service provider, we need to make sure that we're not duplicating IP addresses for a single customer, okay? So in this case, E11 is the internet or the interface facing our data center. So customer Cisco site A, we'll kind of follow suit with the description. So we'll go into interface E11. All right, we'll say description customer Cisco DC1. Okay, and we will give the IP address of we got to be aware of VRFs here, don't we? So if we do show run interface E00, we can see that, right? We have them in the VRF. So there's no need to create another VRF in this particular case, okay? This provider edge router that we're on actually is already aware of the customer Cisco. So we're going to reuse that VRF. That's kind of the whole point. So we'll go ahead and we'll use the same VRF. The only difference is we're going to obviously change the IP address. So in this case, it should be 0.1. All right. Okay, and then we'll no shut him. So we'll do a quick ping. And with any luck, we should be able to ping .2. Okay, good. So that's, just basic connectivity between us and the service provider. We haven't done any routing protocols, so let's do the protocols now. So let's do show run section BGP. So as the service provider, we're running 7029 as our autonomous system number. We're going to come down to the address family for VRF Cisco. So we're going to go to that same address family, okay? And we're going to put a neighbor statement in for 0.2, all right? Remote AS in this case is 65,001, okay? So 65001 based on our key here. We are going to activate him. We can do the AS override just to be safe, but in this particular case, we shouldn't have to, but we'll do it anyway. And then we'll stick a network statement in for the 00/30 network, okay? So if we look at our BGP config, we now have a second neighbor built under the VRF Cisco with all the attributes that we should be concerned with for the time being, right? This may change, but for now, that should be enough to get our peering up between us and them. So for our sake, we should not have any BGP config yet. So we're going to go ahead and we're going to activate the BGP process. Like I said, 65001. All right. We'll say neighbor 192.168.0.1, remote AS 7029. Okay. Let's go ahead and activate him, which will put him in address family IPv4, which it did. All right. Let's see what we learn. All right, so let's do show IP BGP summary. So we're learning 9 prefixes. All right, so that's good, right? So let's see what we got going on. Let's minimize this. So we're learning a 10.100/22. Okay, so that is the network for site A. Okay, that's good. And then we're learning 4/24s, which are the subnets in site B. So it would appear that we are learning all of the networks from site A and site B. So that's a great sign. All right, awesome. Let's go ahead and get the WAN. Let's get the circuit up between WAN 2 and service provider 3. So let's get him going. let's slap a quick description on here. We don't have to, but just so we can see it. So we'll just call it MPLS circuit, whatever, it's fine, right? So same story, we're on we're on WAN 2, so interface gig 6. Description MPLS circuit, we'll no shut it, and in this case it was 192.168.0.6, okay? And that was a /30. Okay. We can go ahead and do BGP since we're on this router now. So router BGP 65001. We will say neighbor should be 0.5 remote AS 7029, and we'll go ahead and we'll activate them. Show run section BGP. Okay. Now let's go over to the service provider. We will show IP interface brief and we will show VRF. All right. So 1.1 is the interface that we're going to configure in this case. We will say customer Cisco DC1 VRF forwarding Cisco. IP address is 192.168.0.5/30. All right. Let's just do a quick ping VRF Cisco 192.168.0.6. Okay, good. The circuit is looking good. Connectivity's there. Let's go ahead and do BGP. So let's drop under BGP, under address family, VRF Cisco, and we're going to essentially just kind of mimic these commands for the data center. Alright, so we'll say neighbor 0.6, remote AS is 65001. We'll go ahead and activate him. And let's go ahead and advertise that /30 network as well. So 0.4 is the network with a mask of /30. We can see our neighbor came up. So that's a good sign. Let's go over to WAN 2. Let's show IP BGP summary. We're learning 10 prefixes. Let's show IP BGP. Alright, so we are learning the /22, which was site A. We're learning the 4/24s, which was site B. And it does appear that we're learning the transit networks as well. So they were the /30s that I had built for the interconnectivity between all the routers. I think this is a remnant of when we were doing internet with one of these routers, so we'll most likely remove this somewhere. We'll track that down and we'll remove it. So I wouldn't concern ourselves with that. Let's just do some housekeeping really quick. So I want to make sure, so let's show run section VRF. Sorry, wrong router. My apologies. Show run section VRF. So for service provider router 1, we have, the route distinguisher and the route targets. Okay, let me blow this up. And let's look at the service provider routers side by side. Cisco, right? Cisco and Cisco. So we've already kind of confirmed that through the routing table we're learning all the prefixes, which means that in this case we didn't need to muck with the route target import export stuff because we reused the VRF, which essentially reused the route distinguishers, right? And we already had the export imports defined from when we did the branch sites. So in this case, we didn't have to, as a service provider, worry about importing, exporting different route targets, all right? Or I should say, you know, route distinguishers. So, and like I said, we verified that with the showing of the BGP table. We're already learning those routes. So that was a kind of verification that we didn't need to do that. Now, the one thing I'll say is if we come over to like site A, router 1, all right, and if we check our BGP table there, we're not learning anything from the data center. Okay, we didn't advertise anything yet, right? That was the whole EIGRP conversation in the beginning of this video. So that's what we're going to accomplish on the next video following this. We're going to start to introduce EIGRP into the data center. We'll start to advertise the 10.101 subnet, if you will, all right? And we're going to start to configure the links. So if I come back to the key, we'll start to configure the links between the WAN routers and the cores, okay? So all the videos leading up to this, we were really heavy in virtual port channels. So in this case, we're actually going to use these links as individual /30 routed links, and we're going to establish EIGRP peerings between the devices. All right. So every one of these /30s is going to participate in EIGRP. We're going to build the peerings, and that's going to slowly start to populate the routing table with all the various routes to get between these devices. And then we'll start to introduce the VLANs that we have configured thus far into EIGRP as well. And then we'll see what we have to do to get those routes to the branch sites. So that's going to be next video. We'll stop here, and I will see you on the next one.